For problem number 3, vectors b and c are shown, and we have to find vector d, which is given by the equation d is equals to vector b minus vector c. We know that the magnitude of vector d can be found by the square root of the components of vectors d on the x-axis plus the component of the vector d on the y-axis. We can find the components of the vector d on the x-axis by finding the components of vectors b and c on the x-axis and subtracting them from each other. Same way that we can do with the components of the vector d on the y-axis. Okay, so let's do it then. The component of vector v on the x-axis is going to be equal, but a vector v on the x-axis is going to be equals to the length of vector v times the cosine of the angle that's forming with the x-axis, which is going to be 33. So we have the component on the x-axis of vector v is equal to 5.6 times, so the cosine of 33 is going to be equals to 0.8387 approximately. So the component on the x-axis of vector v is going to be equals to 4.6966. Now let's find the x component for vector c. Equals to the length of vector c times the cosine of the angle, which we haven't found yet because it's going to be the angle that will form from the x-axis with the vector, which is approximately, let's say 90 minus 22 is going to be 68 degrees. So a cosine of 68 degrees. Cool. So c in x is going to be equals to 4.8 times the cosine of 68 degrees is equal to 0.3746. C on x equals to 1.7981. Now let's just do the same for the y component of both vectors. B on y is equals to the length of b times the sine of 33. B on y it's equals to 5.6 times sine of 33 is going to be equals to 0.5446. And that's going to be equals to 3.049. We could say is 3.041. The y component of vector c is going to be the length of c times the sine of 68 degrees. That's going to be equals to 4.8 times the sine, which is equals to 0.9272. And that's going to be equals to 4.4505 approximately. So now, the length of vector D is going to be equals to the B on X component minus C on X components to the second, because both are going to be to the power of 2, plus the B on Y component minus C on Y component to the power of 2. So D is going to be equal. So before plugging in the values, it is important that we identify the different signs for the X and Y component for both vectors. So for vector V, the X component is going to be negative, and its Y component is also going to be negative. Vector C, its X component is going to be negative as well. I'm so sorry, it's going to be positive, and its Y component, it's going to be negative. So now we can proceed to plug in the values into the equation. So this is going to be, okay, minus 4.697 minus 1.798 plus, so to the second, plus minus 3.04 minus 4.45, all that to the second. So vector D is going to have a value of, I'm going to calculate this on my calculator. I'll be right back. So vector D will have a value of 6.77, which is closest to 6.6.